Today, I'm going to introduce a tool that uses Node.js to monitor uni transactions in real time, helping to catch large slippage. Before recording this video, I was already on social media. I posted a related post, so what's the point of this feature? Well, I can't say it'll make you rich, but at least it can help you avoid some pitfalls. Be sure to watch the video all the way to the end. What do you think its purpose is? Can we use it to monitor the market? Because if there are slippages, doesn't that mean whales are either buying in or selling out? And if this happens repeatedly in a short period of time, if it's detected that he has this many transactions, does that mean there's going to be some market fluctuations? Because usually the market isn't totally airtight. There are definitely some people who have insider info, like Trump's son, for example. Of course, in some meme or shitcoin markets, when you see big slippage happening repeatedly, there's another reason behind it. The liquidity in that market is really lacking. So, can we create some scripts to send out alert emails? That way, you can get a heads up on market trends and make the right decisions. So, for example, things like pulling out liquidity or avoiding trades, or even giving you a trading robot to help optimize your decision-making logic. I mean, the biggest use is still to, if we pick up something like a pending status on the chain, like with some hash here that just popped up a few seconds ago, and this one's about the 2, it's on this uni route, like this uni v4 router here. If you just explain the transaction, you'll be able to tell whether it's a buy or a sell, you know? Was there a couple of transactions just a second ago and they're both still pending? They're just waiting, right? If they go through successfully, once it goes on the blockchain, it will affect the price. So if we have a situation like we just talked about, where I know it's supposed to go on the chain, but it hasn't yet, I'll buy in a bit before he makes his move, and if the slippage works out, he can help you out with the trade. Then you can sell after that. What do you think of this idea? It's good, but there are some downsides too, like the success rate being pretty low. Just think about it. There are 10,000 people in the world using this robot, the claw robot, to look for those arbitrage opportunities. Out of those 10,000 people, only one person can grab this opportunity. The rest won't be able to close the deal because that person has already smoothed out the chances. So, why is that person you? In the end, you'll realize that it's not just about the software code you write. It's actually the hardware, the internet speed, and the servers that matter. And when it comes to servers, having a decent one makes a big difference. There are some hardware devices with bigger hard drives, and when you add it all up, the cost is really high. But I've actually got an idea to avoid some of those high barriers. Like, could we capture that? For opportunities like the one we just talked about that are pending, before it gets on chain, we should calculate where the price might go if it goes through. Then we can base our decisions on that projected price. Let's compare prices with DX. That way, we can avoid getting caught up in the same squeeze where robots are competing for orders. In this situation, the code has about 100 lines, but only a few dozen are actually useful. Here we can see that it uses 2 dependency libraries. One is Ether.js, which is used to interact with the blockchain, and the other one is ENV, which is for storing our environment variables. So the environment variables, it's really not much. There's just one thing, which is our node. And this node is actually a private node. The reason we're not using that public node is that it has a limit on the number of network accesses. Even though private ones don't have restrictions, if a private one is free, there's still this restriction, so I'm applying for it here. You all can check it out too. And then this is a check for an environment variable. It's fine if you don't check this. It's just in case you forget to fill in this URL. Then, when you come back here, there's a field called isWebSocket, which is where you put the WebSocket URL. Copy it over here, and then it will be the pool address, which is our pool's token. We can just go in there and pick any token we want. So the address for one pair here is the LP address. What's an LP address? It's where 2 tokens are stored together, like when someone buys and someone sells. You can provide that kind of liquidity to others, right? And then there's the pool ABI part. If I were a computer, how would I know who you want to connect with? You want to clarify how the contract interaction at an address works. For instance, If you're checking a swap event, make sure to explain how many parameters that swap event has. You need to clearly explain the format for each parameter. Then you use these parameters to create our pool control, which is the instance of this smart contract. You can use this example to get some functions from it, or call them for buying, selling, or checking stuff. Then there's also a function to calculate the slippage. The logic here, I think, doesn't really need to be completely figured out by everyone. If you want to get into the details, it's really about UniV3. The price is based on the square root of the current price scaled up by 2 to the power of 96. So basically, it's the equation we just figured out from that formula. Just know that when I input these two parameters, it can give me the slippage. These two are the current price and the last trading price, and it's a value that's been multiplied by 2 to the power of 96. This is an equation for listening to swap events. It's pretty straightforward. The last price really just keeps track of the price that was stored previously. Lines 56 to 62 are for listening. We can ignore this error. Now we'll use the pool control we just set up to monitor the swap event and collect all those parameters. So this line is basically saying if there was a price last time, more, it can calculate its slippage. If I just started this bot, it doesn't have the previous price recorded. So at first it shows 0. After he finished calculating the slippage, we updated his latest price. When the slippage is greater than 1%, then his script just outputs the relevant data. So I'm sure someone's going to ask, if we're using this pool control to listen for the swap event, does that mean the event is already on chain? Right, it's already on the blockchain, so this line of code can't be used for the clamping robot. If you want to make a clamping robot, then you need to use the object from the provider at this node, which has a function to listen for pending transactions. If it's pending, that means it's waiting and hasn't been added to the blockchain yet. Of course, we keep refreshing this. You can keep refreshing it, and sometimes in the first few seconds, you might see some stuff, but nothing's gone through yet. It's still in the mix. So the clipbot keeps refreshing to check if there are any pending transactions from the last few seconds. If there are, we parse the transaction data and then take action.
For a structured learning path in developing Web3 projects on Solana and other EVM chains, make sure to follow our channel for more tech insights. If you'd like to join our bootcamp, head over to my Patreon. With a free subscription, you'll receive a Web3 project development learning blueprint, outlining the essential skills to quickly build your own dApp. See you there.